Welcome everyone at this live seminar about automatic train operation that we are organizing in the build-up to the Intelligent Rail Summit in Paris. Automatic train operation has been widely used on metro lines for several years now, but the technology is now also starting to be introduced on heavy rail networks. So today we will mainly focus on heavy railway lines. Network Rail has made history last year with the first commercial deployment of automatic train ATO over ETCS on the Thames Link. And we see now that also other countries are experimenting with different levels of automatic train operations on heavy rail networks. So today with me there are two experts who are specialized on automatic train operation. The first one next to me is Rob Goverde. He's professor of railway traffic management and operation at Delft University of Technology. And he's also working right now on an international research on moving block and virtual coupling of trains. The next expert is Sebastian van der Zee. He's project leader at ATO at Alstom. In the last year, Alstom has been involved with several projects and pilots with ATO also on heavy rail networks. So people who are watching right now, you can already start sending in your questions that you have for Rob and Sebastian. And let us start with a short introduction on ATO for the people who are still not that familiar with it. Rob, can I ask you to give a short overview?
Yes, I can. Thank you, Marike. First of all, automatic train operations had several grades of automation. So from basically supported driving to fully automated driving. And that's nicely put in a diagram for passenger trains for urban transit, basically. And this grade of automation go from grade of automation 1. That's actually manual driving. However, the key point there is that there's an automatic train protection protecting for human errors of the driver. So there the automation is in the automatic train protection rather than the train operation. So basically all railways use some kind of automatic train protection except one big exception, and that's trams. So trams actually have a grade of automation 0 in that sense. Grade of automation 1 also includes if you have a driver advisory system that gives support to the drivers, but still the driver is in control and also fully responsible. Then you have the grade of automation 2, which is semi-automatic. So there actually the train driver usually pushes a button and then the train can drive to the next station. On the slide there's also shown a picture of simple button. If the driver pushes it, it can automatically run to the next station. Still the driver is completely responsible. So if something happens, he should be able to take over. And he's also responsible for the door closing and those kind of processes that happen with passenger trains. Then towards driverless operation, it's a grade of automation 3. So in this case, there's no more driver in the cabin. There is still an attendant on board, which doesn't necessarily have to be in the cabin. So he can walk through the train with passengers, for instance, giving information. However, he is available for opening the doors, closing the doors, possibly. And when something happens, when there's a disruption, he can go to the cabin and take over the driving so that he can drive the train in the old-fashioned way.
So he can have someone who has a double role in the train.
Yes. And then the graduation 4, there's nobody actually on the train anymore like personnel. Passengers, of course, usually they are. So that's grade of automation 4. It's fully automated. And that is actually what you see a lot in metro systems around the world. But at heavy rail, the mainline railways, it's more focused right now on achieving grade of automation 2. The present level is currently grade of automation 1 everywhere.
And you have one exception. In Australia, you have the Rio Tinto line where you have no driver on board of the train.
Yeah, so there's a freight line in Australia where it's fully automated, indeed. Yeah.
Okay. Thank you very much for this quick explanation. Mm-hmm. Sebastian also has been involved with recent pilot projects in several countries. Could you explain what findings do you already have?
Yeah, well, Alstom has been working on ATO already for decades, basically on main lines or metro lines. Yeah, we can see on the slide where we already deployed ATO. There are 55 fully automated lines spread over 37 countries. For main lines, we right now are starting up deploying ATO or trying to develop basically the standard, redeveloping the standard for main lines. It's a little bit different than in metro because of the closed environment of a metro, which we do not have on main lines. So therefore we need to basically discuss the standard, define it in a subset of ERTMS. And this subset we have been testing recently on beta route. Last year we performed a series of tests with the locomotive from RRF.
So what you were saying about ERTMS, that's the safety system, and the combination is of automatic train operation combined with ERTMS.
Yeah, exactly. So this combination of ATO over ETCS, we call it, has been put to the test. We performed these tests under grade of automation level 2.
Where there was still a train driver on board.
There was still a train driver on board, but this train driver was supported by a system who was automatically accelerating and braking. Well, during these tests, we have learned a lot. Let's say it like that. The human behavior was one of the most important findings that we found out that it's very important to see how a train driver runs his train, and that's something we had to basically copy into our algorithms for controlling the train. Well, during the train testing on beta route, we were in a live situation, so there were other trains behind us and in front of us. So we had to be not very careful because we're having the safety envelope of ERTMS, but we could not stand still for hours, of course, because we then blocked the entire beta route. Well, during the train drives, we had several updates during the testing. So it was a very iterative, agile process on developing. But what we saw is that, after several software updates, the regulations of the train, so the way the train was controlled, were becoming more reliable and more accurate. So the stopping points before the signal marker boards, we do not have signals on ERTMS. We just stopped several meters in front of this signal marker boards in the end. So the accuracy was flawless in the end. Also, the train driver who was performing the tests was driving the train, and also the process leader of the test leader. We call it the BPRL. He was a very experienced train driver, and what he basically said in the beginning, or in the end of testing, that he could himself drive more efficient. However, he also mentioned that he could not stop that accurate on a certain position. So that's basically also something. Nice feedback, of course. ATO, the benefits of ATO, it could be that it's either energy efficient, or it could be, we see it also in this slide, it could be also maximum capacity. That's basically, you cannot not have both. There could be a mix, but it's either high capacity or high energy efficiency.
And those would profit also on a freight line, because you have many freight trains behind each other.
Yeah, well, for a freight line, there's not a real need for high capacity, other than we do have. We want to drive our goods to Europe through Europe in an efficient way. So energy consumption, it's huge. I heard a story once that a train starting up to full speed could provide the entire city of Rotterdam for several seconds of energy.
Wow,
So
that's a lot.
it's a lot. It's a lot of energy is involved in these kind of things. So if you can reduce that energy, yeah, it means that we are doing a good job. The savings are the benefits of ATO are much higher than the investment cost in the end. Yeah.
Oh, thank you. And you have also done a pilot project in France last year, where you were driving a train from a remote control.
Yeah.
And you have sent us a little video that we can show to the audience. And
Yes, exactly.
I would like to ask you to comment on that, to explain what we are seeing.
Yeah, happy to.
Yeah, let's start the video.
So this is basically something we call remote cab, driving automation program. We performed a series of tests with a remote control station in Lyon. And we had a train who was at the test center in Valenciennes. Well, here we have basically an unmanned cabin of the loco, and the train driver sitting 500 kilometers away from the train itself. He controls the train by a display. You can basically release the brakes, set the direction, raise the pantograph, and just start driving with the traction braking handle, which is also sensing the hand of the driver, like a dead man switch. So the loco is equipped with several cameras, which are providing the driver with a real-time video on high resolution, and the algorithms are basically made for to have a low bandwidth usage, so that you can send as much video feed as possible. Well, as I mentioned, the dead man switch, the driving handle is protected. So you have to pay constant attention to what you're doing. Well, stopping, in the end, putting the pressure on the brakes again. Yeah, this is something we did over a year ago at our test track. Well, this is something I think would help a lot of operators in, for example, starting up their morning shift. It's a huge operation to send your drivers into, basically really dark shunting areas where all the trains are parked. It's a very logistic operation at the moment. I think this remote cab could solve these issues by starting up, for example, the morning shift by remotely controlling trains and remotely driving the trains towards the stations in a real easy manner, without putting the drivers at risk, walking over a shunting yard with all moving trains, etc. Also for freight operators, this could be a huge advantage for shunting their locomotives through the yards. In Rotterdam, we have several yards interconnected through mainline. One driver needs to go to another yard. He has to take the car back to go to his original destination. It's a lot of moving around people.
So there's a lot of benefits for train drivers also in the morning,
exactly,
and
exactly.
at the end of the shift.
Also, for example, going to GOA 4 for freight operation, for example, it could also assist the operator in case of degraded mode, something wrong with the train. It's saving basically the attendant on the train, because they can remotely connect to the train, and they can drive the train back towards the stabling yard or a workshop to fix it.
So Rob was wondering, what are the main obstacles that you still have to face to make automatic train operation possible?
Well, one of the things, so it already works in metro systems. So if you consider main lines, you're working in an environment where there's much more dynamics, more stochastics in a way. So you have the environment, different weather circumstances. There are usually much more different types of trains. There's also different type of trains in terms of intercity sprinters. So they have different stopping patterns, different speeds. So the environment is much more difficult. When you, in first instance, think about ATO, it's all train specific. So you have a speed profile that the train has to stick to. But if the train isn't able to adhere to this schedule, you need to also be aware of this. So I think that the main obstacle is to monitor all the traffic and have some kind of traffic management system that also automatically monitors deviations and when needed sends new targets to the train so that the train the train that's behind the train that's a little bit delayed also at dwelling when a little bit it takes a little bit longer when people board the trains, that you can adjust it smoothly.
So what you're saying, if you're implementing automatic train operation, there should be also in the traffic center should be automated.
Yes, so there should be an automatic traffic management system that is connected to this automatic train operation to send state-of-the-art or actual targets to the trains. So running according to a timetable is the basis, but if you deviate from it, it should be quickly checked if it could be changed. What you want to prevent is actually that a train has to stop, because automatic train operation is still below the automatic train protection system. So the ATO can do also things wrong, where it could, if there's no movement authority available, it has to stop before the end of the movement authority. So you have to give advice what the optimal speed profile is. So you can compute it according to the timetable, but if the timetable is not valid anymore, you have to come up with new targets and then on board the train or from the traffic control center, you have to come up with new commands to have a new speed profile. And this process, so more the interaction between trains is something that still needs to be tested, evaluated, and also in combination with this automatic train operation running of trains.
Yeah, we have tested some of this as well on Beetroot. It was ATO on board, but besides that, we also tested the ATO trackside, which was basically calculating a journey profile for a train, taking into account also other trains. So we also were sending a journey profile for a train, which was, I think, sometimes up to 40 kilometers. So for the next 40 kilometers, it knew exactly where to drive what speed, also taking into account the path of other trains. And also we also tested the ATO trackside part with updates of this journey profile. So some events taking place during operation. A train was blending in, for example, how ATO should behave during these kind of events. So perhaps then the optimal speed was not 100 kilometers an hour, but 60. So just in order to avoid it to stop.
You just want to keep the trains running
exactly
in all costs.
Well, starting up from standstill is something you not want. You want to avoid standstill because that takes several minutes to start up again a long train.
Yeah. I see that there are already been some questions from the audience, so let's take a look at them. Let me see. Stephen Smith asks, how positive is the business case for GOA 4 on mainline, and what do we know about that? Who wants to respond to that?
I think GOA 4 on mainline is not really the goal, at least not on say the next 10 or 20 years. So I think it's really GOA 2. So where there's still a driver, so going forward might be interesting for short parts. So if there's a bottleneck, for instance, around the Schiphol area, then you might consider a slight part of Creative Automation 4. This is also the intention in the Thameslink in London. But when you pass that bottleneck area, you could go back to Goa 2 or even lower, where the driver is responsible. Because if you want to have fully automated train running through the entire Netherlands or mainline networks through the fields, etc., you also need to take care of a lot of environmental conditions. While the driver has, besides controlling the speed, he also has different other roles. And one is actually inspecting the track in front, and this is something you can do in these urban environments or so. You can kind of close it up, but throughout really kilometers of things, you might think it could be actually easier to do it with Goa 2. So I don't think that the ultimate goal is to go up for a complete big mainline networks, but it's more at bottleneck sections. And as Sebastian already mentioned, for instance, shunting, then it's really interesting. Then there's actually no passengers on board anymore, so that the train is basically shunted away, and that can be done automatically or even remote control. So that's kind of in between, I would say. So it's not that you have to choose a certain creative automation, but probably it's a mixture of creative automations that you apply where you need it.
Yeah, so the train driver, the task of the train drivers will be taken over by the ATO systems on certain parts of the railroad, or maybe for the shunting or at the end of the lines. It will not be like there will not be a train driver on board anymore. Yeah. Okay, so let's go to the next question of Beatrice Asensio. Has this ETCS combined with ATO follow the plan of ATO specification that will be added to the CCS TSI?
Well, we've tested it according to the current Unisys standard. That's basically what we tested. ATO is a SIL 0 system in the end. Well, I'm not sure whether it has been tested against these specs, but yeah.
So in general, the ATO of ETCS specifications, they are being defined. I think they're almost done, but not yet finished, and they will end up in some baseline of ERTMS in the coming years. So I think now that the pilots are based on those specs.
Yeah.
Last question in the screen is one big discussion for Go 2 is the risk of degrading attention for drivers, and how is that dealt with these attention laws? And another question is how is dealt with legal issues, ATO taking over tasks from train driver? Bob, maybe you want to answer that one?
Well, that's the key issue, of course. If you take drivers out of the loop, the attention drops. So if you are driving the train yourself, you're completely aware of what you're doing. If it's partly automated, it might be difficult. So if you have to get back, so if somehow the ATO system thinks, I don't know what to do, so please driver, take it over for me. At those moments, you have to be aware. So this is something also that is researched a lot with car traffic, with automated cars, automated vehicles, with cruising and getting back to it. For the railways, there's always this safety net on top of it, the automatic train protection. So in terms of safety, there is not an issue, except the driver has to be aware. What you could do is warn drivers or indicate when, for instance, you approach level crossings or so, that you're aware that you may pay attention a little bit more, because the driver is in the end responsible for driving the train.
And then how do you think about the combination of driver advisory systems and ATO?
Driver advice system is basically gives an advice that the driver then carries out. The ATO actually could carry out that same kind of advice itself. What you could think of is that if you have a bottleneck area like the Thames Link in London, that you have an automatic train operation, creative automation 2. So there, the driver pushes the button and you go to the next station. You repeat that 7 times. And when you go out of this area, you could you could manually drive again. But since all the information is available on the train, you could also use it for a connected driver advisory system. That works basically the same then as the ATO system. And I think that that's a good idea in the sense that the drivers are then also aware how the speed profiles that the train guides you to, how that works and how this is working. So that's also when the ATO itself is driving, that the driver also understands what the automatic pilot is actually doing.
Yeah.
And I think that's the key. If the train is doing something unexpected, you should really avoid this. So there's really research line to look at the human factors part, that the train shouldn't do something as a black box, but somehow it should give information to the driver, what it's doing,
that
why
they know
it's
what's
doing,
happening.
and so that the driver can quickly be in control again.
Sebastian, do you want to respond to that?
Well, drivers already have less things to do compared to the former ATB systems. All the braking curves are automatically being calculated. The driving distance is being provided to the train driver. So, well, supporting the driver with how he or she should accelerate or brake. I think it is something providing some additional safety, for example, but also
could you give an example, some additional safety? What would that?
Well, train driver, like they could always make mistakes. It's human behavior. Passing a signal at danger is something when you do not brake at a certain moment, or just put on your standstill brakes. I'm not sure how you call them in English, but you could roll beyond a certain point. You have you pass the signal at danger. It's still possible with even within the safety envelope of ERTMS. With ATO, it just always stops in an accurate way on a place where it's supposed to stop. These kind of things are avoided. The driver has more has more time to react on what's happening outside. Also, in case on Beirut, we have several voltage changeovers, for example. They have to do a lot of handling of lowering pantograph, raising up it again, switching from let's say transition from ATB to level 1, for example.
So there are several activities for the train drivers to keep their attention.
Exactly. Well, that can distract their attention from driving the actual train. So these kind of exercises are basically supported by the ATO system. So it could give them more attention to what they're actually supposed to do, and that's watching what's happening outside and bring the train from A to B in a safe way.
And I think besides a safe way, it's mostly about avoiding a disruption by having to stop at standstill. But more proactively, an ATO profile can actually anticipate on the driving and avoid that you have to stop for a red signal. And that, of course, has a lot of influence because trains can queue up because the train is standing there and it's taking longer than it was supposed to be to occupy the track. So rather than safety, I would say it's more about avoiding disruptions to the traffic.
Yeah.
In the ideal situation, you would never face a red signal.
No.
Yeah.
Only when you reach your end destination.
Thank you. I see another question coming in from Jean-Pierre van der Waal. If applied to freight trains, what kind of infrastructure is required at terminals, loading and unloading points to handle ATO? Who would you like to?
Well, for the
answer this question?
infrastructure, the endpoints, you're still working with signals, but at a certain moment you are going from managed ETCS or UTMS level 1 or 2 or 3 to unsignaled area. We call it non-centrally controlled area. Yeah, at that moment you do not have the safety envelope of your TMS, so you have to have an you could have for example the remote control taking over at these kind of uncontrolled areas in case of an unmanned train. On the other hand, when the train stops, it's also possible to take the last mile by a drive, for example, to somebody who shuns the train according to plan.
Yeah, so of course, if you think about automatic loading and unloading of freight trains, there's a lot of machinery around it, like in the harbor in Maashaven. Yeah. And ATO is just the running of the trains part. So then its task would be to stop at the right positions and then drive again.
Yeah.
At the end of the year or beginning of next year, there will be an auction of the frequencies that are required for a 5G network. And what kind of impact could this have on the ATO technology? Sebastian.
Well, the ATO technology itself, not much, because ATO itself requires very little bandwidth. You could even do it over GSMR, I think. On the other hand, it creates for the video feed, so for example the remote cap, it creates a low latency connection, which you have much more real-time video feeds. These video feeds, the delay of the current 4G standard is more than 5G is at the moment. So 5G will create a low latency connection, real-time images from outside. For example, we already thought about you could also, for example, put a camera on level crossings. So a train driver knows already in advance, 3 kilometers in advance, how the level crossing is looking like. These kind of images could also be provided to a train driver, for example.
Much more information with
exactly.
a quicker network.
Right now he has to look outside of his window and he can basically see the level crossings in a detailed way from a kilometer up front. A kilometer up front with the speed they are traveling, basically you're always too late. So 5G could also offer these kind of solutions, doing much more with video streaming. But protecting people on the level crossings in case of an emergency with a wheelchair being blocked, a train driver being notified in 4 kilometers or 3 kilometers in advance of a level crossing could mean it could save lives, for example.
Rob, if you look at a quicker connection for the communication system, what would that mean for future technologies, also the technologies that you are doing research on at this moment?
Yeah, so at the moment, all on mainline railways, they usually use a fixed block signaling concept and absolute braking distances. So that means that basically from the beginning of the railways, it is assumed that the train has to be able to stop before a next train. So that's the absolute braking distance, so-called brick wall principle, so that if a train derails, the next train would stop in time before that one is also failing. So we're getting more and more capacity problems. We want to have much more trains running. Actually, we're also investigating other principles where we leave this brick wall principle behind and see comparable to what happens on roads. If you look at roads, if you compare, say, a high-speed train that has an absolute braking distance of something like 5 kilometers when it's running at 300 kilometers per hour, well, and at a highway you see cars 1 or 2 seconds after each other. So that's a completely different world of using capacity. So this concept is now also being investigated in the railways. I'm involved, I'm the coordinator of a moving rail project that's doing this. It's one of the projects where we look at the relative braking distances. So here we have now train-to-train communication, and the leading train, basically, if it's braking, then a train behind is actually coupled to this train in a virtual way, so that it can quickly respond to this leading train. And there might be a convoy of several trains behind each other that actually all act as one. So if one starts braking, everybody starts braking. And for that, of course, you need way much more accurate communication. That you immediately, when the leading train brakes, the other trains also brake. And you need to communicate between those trains, like there might be different characteristics of the train, so you also need to be aware of this, so that there's much more communication going on.
You gave an example earlier about high-speed trains that have a braking distance of 5 kilometers. So if you would look at the actual braking distance, there would always have to be 5 kilometers in between them.
Yes.
With this new technology, it would be possible to move them closer.
Yes, move them much more closer. And it also depends on what happens around a station area. So what you see is when the trains actually slow down, also the braking distance becomes lower. So if the trains can run, say, at 1 kilometer or so at these high speeds on a line, and when they approach a station and they're all slowing down, also there you will see that the braking distance actually reduces. And if the trains want to go to different platform tracks, then at the switch, where of course you still need this absolute braking distance, that would be then the new bottleneck to make that happen. Because at switch technology, at least current technology, is that you have to be guaranteed that the switch is in the right position before you can move into its approach distance, so to say. So if one train goes to one track and then the switch has to reverse to another track, only when it's locked, the other track, the next train may be in the braking distance go over that switch. So that would be then the bottleneck, but those again are at lower speed, so then the braking distances are also small again. But if you're running on high speeds on open tracks between stations, you can get much closer. So that's one of the opportunities that you have to get trains, with a higher frequency on those tracks.
And
putting more intelligence in the train itself.
So in this case, actually, it is signaling because it's safety relevant that you respond to each other train, but it's also completely automatic now. So this combines automatic train operation with signaling. That somehow indeed, you have an intelligent train, but actually a convoy of trains that for the outside world, so for the station safety systems, the interlocking systems, the traffic control, they are one big train. But within this train, actually, there are several trains that are interconnected by this train-to-train communication that act as one. And when they decouple, so when they approach a station and they want to go to different platforms or so, then they would decouple and they become separate trains again.
So you could compare it to truck platooning, what they're also doing on highways.
Yes, it's similar like platooning on highways, indeed, which are also piloted investigations.
Very interesting.
Yeah.
Let me see, there have already come some questions from the audience. It's a question from Rens Bloom. How would you prevent cybersecurity vulnerabilities with the ATO? Who wants to respond to that one?
Well, cybersecurity is, of course, a very important topic. On the other hand, ATO is a zero system, but you still have to think of how your architecture should look like. So, the current GSMR protocol for railways is decades old already, and still, we are managing it in a rather safe way, but we rely quite a lot also on our closed environment of railways. This is becoming more and more important because we're opening up our railway system much more. We are going much more through air. So yeah, definitely a very important topic to pay attention to. Yeah, it has our attention for sure.
And then, Rappo, how is your view on future communication systems and cybersecurity?
Yeah, it's definitely one of the top priorities to have safe telecommunication. So in the still a lot in the railways is all track based or infrastructure based, train detection, etc. The more and more you make the trains intelligent and rely on wireless communication, the more dangerous you come from cyber attacks, outside attacks. So you have to be prepared for that and actually to be able to prevent it. So cybersecurity and more and more wireless communication within railways should go hand in hand.
Yeah, the communication also for example, ATO, we had several tunnels also. So the communication was lost several times as well. Well, that didn't matter to us. We have a journey profile loaded into a train and it stays valid up until this journey profile is being updated. So yeah, communication loss for ATO, for example, shouldn't be much of a problem.
That's also one of the questions that was sent in.
So it's actually more the signaling, right? If the signaling is still communicated, so say the European Traffic Control System, I think the ETCS signal, that should of course be always safe, as long as the ATO stays below that boundary given by the automatic train protection system. It doesn't matter what happens that much. But for the ETCS, there's much more specifications that a signal can't be lost that long.
Yeah, in case of all communication is lost, also the GSMR for the ETCS, the train stops. It's simple as that.
There's another question coming in from Costa Radu. I guess maybe that's also what happened on the beta route. On the same line track and coexist the ATO system and a classic system with the driver.
Well, yes.
Yeah.
On beta route we did an ATO over GO82 with the driver. So the driver is basically supported by the ATO system. So yeah, they coexist for sure. Under GO82, it's of course mandatory to have the driver still in the train.
Yeah.
I know a similar situation, for instance, in Sweden, where they have a driver advisory system. And some of the trains are connected to this driver advisory system, and then they can actually have contact communication with the traffic control center, so they're kind of predictable. But in between, there's also trains without this driver advisory system. So it's the traffic control systems and the connected trains do not know how those trains actually are running because there's no communication between traffic control and those trains. So that's something that makes more uncertainty, and that is at the cost of capacity in that sense.
Yeah. And in the end, all the DOS-alike systems, all the driver support systems, there are several driver support systems for them, avoiding them to pass a signal at danger, for example. Also the DOS system, of course. The need for these systems is existing because we still haven't deployed the ERTMS outside. Well, in case we have, we're starting up now the ERTMS, Pro is starting up the ERTMS rollout. Having ERTMS on a line would also enable ATO over ETCS, of course. So that means that all these kind of support systems like DOS and like Orbit, would no longer be needed for a driver because it's all handled by, one system, basically. Yeah, we see ATO as, I have a dream that ATO in the end would be a standard in each train running over ETCS. So not seeing it as two different systems, but as one. That should be the case, I think, in the future.
Yeah. Thank you. Let me see. We have another question. Have you used methods like simulation and artificial intelligence to investigate the effects and benefits of ATO? especially with respect to improving the ATO behavior, implementation of traffic management systems, or calculation of an OSP. Is this question clear? Would you
Yes,
like to answer?
we do a lot of simulation tests and exercises. Of course, it's actually quite interesting how to simulate an ATO train rather than a manually driven train. And you could say, okay, an ATO train is just following the plan, right? Then it's quite a deterministic simulation, and it's not that exciting. While that would also be the typical way you simulate the human driver. So there is a difference. So there's a difference in the reaction times that the human driver has and that the ATO system has. And there might be difference in the way stochastics are being dealt with, or how you interact with the traffic management system and the ATO system. So that's another kind of simulations that you test all the communication data and the response times of those things.
Yeah. The simulations are, of course, ideal to check how blending in is affecting the schedules of ProRail, for example, and NS. Blending in, for example, of
merging of trains.
merging of trains. So when you have a crossing corridor in the Netherlands, we have the beta route and the crossing corridor, the A2 corridor. You can send a freight train from the beta route towards the A2 corridor at Meteren, for example. Blending in these kind of trains into the train service for passengers, for example, is of course it could be a very disturbing process. But with ATO, you can aim directly at a certain window and just let your train go into this other traffic stream in a fluent way. So
the A2 corridor is a corridor between Amsterdam and the south of the Netherlands, where
Utrecht Den Bosch.
Whereas every 10 minutes is another train, a passenger train, and then you have the freight train coming in with a lower speed, and therefore you need that combination.
Just let it blend in on maximum speed in order to avoid any disturbances in this passenger operation.
So basically you have a stream of passenger trains, and that has of course a headway in between them, and the headway should be big enough for the freight train to merge in. So if the window is big enough that actually there could fit a train in between, then you could compute if the freight train is coming from the beta route, the optimal speed to enter this main line at the right speed, so that it doesn't interfere with the next train. Of course, if the window is too small, then there's no other way, and it still blends in. Then the second passenger train has to reduce speed because it will see yellow signals or red signals. Or it could also be that, and there you can also simulate this passenger stream of trains. And this freight train also have to check, okay, which gap would be big enough to go there. And then you actually can already in advance to this stream, minutes in advance, or maybe 10 minutes, try to find the right spots. But that would actually be a quite advanced interaction between some kind of traffic management system that decides between which trains. So the route has to be set between which trains, and then the speed profile of the freight train to enter those trains. And of course, if you have completely control of both the passenger trains and the freight trains, then you can really optimize such a situation.
Okay, let me see. There's if there are another question. Let me see. Oh yeah, one from Jordi Rieuken-Graas. Does the ATO need or can benefit from environment perception sensors, LiDAR, 3T, imagining LiDARs? LiDAR, sorry.
LiDAR, yeah.
Sorry.
That's most probable solution you could put into tramway. Well, looking with LiDAR 2 or 3 kilometers in front of you, it's impossible. It simply cannot work. So
because the braking distance is too long.
Exactly. Well, that's a problem. So I'm not sure how far these sensors could reach. For example, LiDAR, but I think it's 100, 200 meters for the the laser dots to reach a target, then it has to be processed. Your train is already past that point at that moment.
Okay.
I think that's also a big difference between car traffic that can, just look 200 meters ahead or so. That would be fine. But for railways, you have to look much farther ahead.
So not every system that is suitable for automotive is also suitable for rail, because
we can learn a lot from automotive. Well, I'm sure of it. Like Tesla is doing now with their cars, they just they have the most automatic driving vehicles in the world. They have the most knowledge about these kind of systems. We can learn a lot from other industries. We should. We are doing basically kind of unique activities within railway. It's a very low amount of systems we deliver. For example, for ATO, several thousands of trains in the Netherlands, for example. It sounds much, but it's still
it's not that much.
It's not that much compared to the 500 cars Tesla was delivering last week in the Netherlands per day. So just compare that with the trains. So we can learn a lot from these kind of industries. Yes.
On the other hand, they can also learn from the railways, because what we have in the railways already satisfied is the automatic train protection. Right? That works. That could be better, like ETCS than ATB, but it works. This is something that is always as a supervisory system on top of or below, on top of the ATO systems. And that's something that on car traffic they are now considering also. Okay, how to do with safety if the driver wants to merge and when things happen that you didn't consider yet. This is something that the railways have as an advantage.
We're running out of time, so I would suggest to do one more last question. Let me see, Pavel Kolecki. I hope I'm pronouncing this right. Rob, how would you test the benefits of large-scale implementation of ATO as well for potential problems in the transition period?
Well, to start with transition periods, ATO, I'm thinking about Creative Automation 2, of course. I mean, Creative Automation 1 would be kind of easy answered because we're already there. But so what about automatic train operations? Actually, I think it would be a good idea to start with connected driver advisory systems, where you connect everything and give advice to the drivers. Still, the driver is in the loop, is still running the train. And what you can also see is if there's something wrong with these algorithms, you can actually learn from it and improve it. And the next step would be to put that in an automatic train operation, Creative Automation 2, where the train is actually running itself. But really, it's important to give always information to the driver so that he knows why the ATO system is doing what it's doing, so that he can always intervene. If there's anything in test periods or so, things with communication problems, etc., still the driver should be able to drive himself again. So back to GOBA 1 modes, possibly with driver advisory systems or not. So the ATO is something additional. It's in that sense, it's not as big impact as rolling out ERTMS.
It's a very small component within the ERTMS platform, ETCS platform, which is on board. It's a very small component within that platform. It's just basically an interface, for example, with the traction braking handle. So on the beta route, for example, when ATO was enabled or engaged, we say, once you are putting the brake handle into a certain braking mode, the driver automatically takes over. So there's nothing. It's not interfering with the driver on when he wants to take over, for example. It's just like an autopilot. It's when you want to go back to manual, it automatically jumps back to manual. So the driver is always able to take over the
Take over
control.
control.
And that
Yeah.
should always be. Of course, the question is, do we wait for ERTMS to be installed before we can allow ATO?
Because the ERTMS will be installed in 2030 on a certain
Well,
railways, for example,
So
in the Netherlands.
yes, so in the next decade we will migrate some lines in the Netherlands to ERTMS. So in 2030, some important lines are equipped. But then we are a decade further, and the question is, do we want to have ATO already before that? And then we really have to look carefully on the existing automatic train protect systems. For instance, areas where there's just green signals, you can automatically also have this ATO system, like you would have a driver advisory system, which not that much appeal. Become a little bit more critical when you have to start braking, or when there's a train ahead, or you have to stop. So that's something that's now research is being done how to deal with this. For instance, there's also a pilot in the north of the land between Groningen and Leeuwarden. That's ATB new generation. So the question is, okay, what can you achieve with ADO on the existing signaling systems? And when you have ETCS, then everything, all the communication is well prepared, and it's quite easy.
Yeah, that makes it a piece of cake. We also trying to work on signal recognition. On the beta route, we also included some cameras which were installed on the train for both object recognition and signal recognition. This basically works on we have a database with all the types of signals and the coordinates of the signals, so the system could read the signals that it is passing. On the other hand, we are also looking into ways on how to deploy ATO on ATB, first generation, and NG indeed.
NG is what they're doing in Groningen.
Exactly.
At this moment.
So we're still not there yet. ERTMS in the entire country is still far away, and we have an urgent need for higher capacity. That means for the Netherlands that we should shift to 3 kilovolts on the catenary, but also to ATO. It's one of the three major topics ProRail is struggling with at the moment. So, focusing on ATO over ATB, no matter which version in the Netherlands, has our focus as well. Yeah.
I think that is a nice conclusion to end this webinar. I want to thank you both for your explanations. And I also want to thank the audience for participating in this webinar and for the questions that you have sent in. And of course, in the Intelligent Rail Summit on the 19th, 20th, and the 21st of November in Paris, we will talk further about this topic. And we will have several international experts who will go into this topic further. We will speak on the 20th, we'll speak about automatic train operation. On the 21st, we'll speak about the digital railway. We will have a presentation of Banen Denmark, Infrabel, SER, Shift to Rail, Arriva, and many more. Rob, you will also be chairing the first day. I'm looking forward to that. And I would like to invite everybody to join us in Paris. You can find more information on intelligentrailsummit.com. Thank you all for your attention and hope to see you next time.